All right, so day 3 of establishing identities, same idea. This is straight up practice. There's no new information here. It's just practicing what we've been doing. Okay, so per usual, when I start, I'm going to write my 3 trig identities right at the top of my paper so I can refer to them. Once again, we have sine squared of theta plus cosine squared of theta is equal to 1. Tan for 1 second, tangent squared of theta plus 1 equals secant squared of theta. And then 1 plus cotangent squared of theta equals cosecant squared of theta. So those are my 3 trig identities. Make sure you know them because they will help in some of these problems. Okay, so first thing I have to do, remember, is I have to decide which side is more complicated. This left side here that involves fractions and subtraction is way more complicated. Okay, so I have to decide what I'm going to do first. So I say to myself, okay, I notice that it's 2 fractions being subtracted, and then on the right side, this is just one term. Okay, it's separated by multiplication, so that's technically just one term. So I need to make that left side one term, so I'm going to subtract them. In order to subtract them, I need a common denominator. So first I'm going to say what's my common denominator, and that is 1 minus sign times 1 plus sign. So I already have a 1 plus sign here. I already have a 1 minus sign here. I'm going to multiply this by 1 plus sine of theta. But then I have to do that to the numerator also, 1 plus sine of theta. And then this one I'm going to multiply by 1 minus sine of theta. And the denominator I also have to multiply by 1 minus sine of theta. Make sure you want to show that you're doing that. Notice I just squeezed it in there. Okay, so whenever I am making 2 fractions 1 fraction, I make it 1 fraction in the next step. Okay, and I make the fraction bar pretty long because there's going to be a lot of stuff in the numerator. Okay, so in my denominator, I have my common denominator, which is 1 plus sine times 1 minus sine. And then I'm going to put the equal sign there, okay? In my numerator, I have this times this minus this times this. So I'm just going to write it all out just so people don't say, like, where did you get that from? So I have 1 plus sine of theta times 1 plus sine of theta minus, and then 1 minus sine of theta times 1 minus sine of theta. Could I just multiply this out right now? Yes, but I just don't want to lose anyone. Okay, so now what I'm going to do is I'll highlight what I'm going to actually do. I'm going to multiply these 2 out, and then I'm going to keep the minus sign there. I'll multiply those 2 out, and I'll also multiply these 2 out all in one step. Okay? All right, so I'll start by multiplying the first 2 out. I'm going to use the distributive property or foiling. 1 times 1 is 1. I'm going to actually make my fraction right now. 1 times 1 is 1, that's first. Outer is sine of theta. Inner is also sine of theta because it's 1 side of theta and 1 side of theta. So I'm going to do that mental math and say that's plus 2 sine of theta. And then last, sine times sine is plus sine squared of theta. Now realize it says that you are subtracting this whole entire thing, what you're getting. So I'm going to put minus, and then I'm going to put brackets down like this to know that whatever's in that, I have to subtract the whole thing. Yes, you can use parentheses, but you know how I have a love for brackets. Okay, so now I'm going to multiply these 2. 1 times 1 is 1. Outer is negative sine of theta. Inner is negative sine of theta, so I have 2 of those. So I have minus 2 sine of theta. And then last times negative sine is plus sine squared. Let me move this over just a tad. Whatever. Plus sine squared of theta. Okay, I don't like the way that looks. You know how I feel. Let's go like this. Plus sine squared of theta. Bracket. Okay. Now for my denominator, I have 1 times 1 is 1. Outer is negative sine of theta. Inner is positive sine of theta, which cancel out, so I'm not going to write them. And then last times last, sine of theta times negative sine of theta is minus sine squared of theta. So now I have this, okay? So what can I do in my numerator? Well, I can distribute that negative. I can subtract everything. So that's what I'm going to do. I'm going to subtract everything. So I'm going to change it to plus by distributing the negative. This becomes a minus. This becomes a plus. This becomes a minus. And now in my numerator, I can combine like terms. So I have a 1 and a negative 1, which cancel. I have a 2 sine of theta and a 2 sine of theta, which is 4 sine of theta. Now you might be saying like, oh, are they supposed to cancel? If you look at what you're trying to get here, there's a 4 in it. So no, it's not. Okay, then I have a sine squared of theta and a negative sine of squared of theta, which cancel. So that's all that I got in my numerator. So that's great. In my denominator, I have a 1 minus sine squared. Now, perfect square, perfect square. So I say, ooh, trig identities. What can I replace that with? Or I can be like, I don't know what to do next. Let's say I say that. If I don't know what to do next, look at what you're trying to get. You're trying to get a tangent and a secant. Okay? Tangent is sine over cosine. So that means I need a cosine down here. Secant is 1 over cosine. That means I need a cosine down here. So I need to get cosine down here instead of 1 minus sine squared. That's another way of thinking about it. Okay. So 1 minus sine squared, I'm sure it's no surprise that it's going to be cosine squared, but just to show you, 1 minus sine, 1 minus sine squared, I would have to subtract sine squared off of this side and get onto this side, and I'd be left with cosine squared over here. So this is replaceable with cosine squared, so I'm going to replace it with cosine squared of theta. Now, once again, if you're stuck and you're like, I don't know what to do next, look at what you're trying to get. You're trying to get a 4, a tangent, and a secant. We already have the 4, so I'll just rewrite that as 4 over 1. We need a tangent. A tangent is sine over cosine. We got one of those. Sine of theta over cosine of theta. Times, times, times. A secant is a 1 over cosine. We have that. I don't like that times sign right there. It looks like a plus. 1 over cosine theta. So what I just did is I broke this up into this. Now, if you're saying like, oh, can you do that? Can you go this way? Yes, that means you can go that way, right? Okay, so now you can say that this is 4 tangent of theta, secant of theta, which is equal to 4 tangent of theta, secant of theta. Once again, notice you're writing nothing on the right-hand side unless you're writing this here, 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 and here. There's nothing else that can be written there. Do not move. Don't say your handwriting's too big. Don't do it. Okay. Next one, I have to pick which side is more complicated. So the first thing people will always suggest to me is to cross multiply. And I say, remember, when establishing identities, you can only touch one side. Right? You cannot touch both sides. So you have to pick the one that's more complicated. So to decide which one's more complicated, when they both look almost identical, you're going to look at the denominators and say, okay, well, which denominator is more complicated? The one on the right. So we are going to manipulate this side. Okay, so what can we do to this side? So I always ask people, what can I do? And they'll say, oh, you can change cotangent to cosine over sine. That's not going to help me because if you look, I'm not trying to get any cosines or sines, so we don't want to do that. So what I would say is, okay, what can I do whenever I am working with a fraction and there's 2 terms down here? Whenever there's 2 terms down there, you can multiply by the conjugate of the denominator. The conjugate is cosecant of theta minus 1. Cosecant of theta minus 1. You're going to multiply the numerator and the denominator by that. All right, let's write down what we have. We have cotangent of theta times cosecant of theta minus 1. And then we have cosecant of theta plus 1 times cosecant of theta minus 1. Okay? So now people always ask, not people always ask, but you have to think about what you can do next. So in my numerator, I can distribute. Is that going to help at all? Okay? No, it's going to make it more complicated. right? So I'm just going to leave it. And if you're like, wait, how do you know? Because it's going to be cotangent cosecant minus cotangent. That's more complicated. What if I distributed my denominator? Yeah, I want to distribute my denominator because this is going to become less complicated. Because remember, when you multiply conjugates, the whole reason you're doing that is because something good happens in the denominator. So let's do that. First times first is cosecant squared. Outer is minus cosecant, inner is plus cosecant, so they cancel, like they always will when they're conjugates. Last times last is -1. My numerator, cotangent of theta times cosecant of theta minus 1. Now I want you to realize is that if you skipped this step right here and you're like, oh, I knew to multiply, let me do this really quickly. I knew to multiply the denominators because that's the whole point of getting a conjugate. That's fine. I'm fine with that. I know you know to do that. Okay? So if you're like, I did it right here, that's great. Okay, so now let's see where we are. So I have to say to myself, okay, what can I do next? Because I do not have this, right? And I say I'm close because I got this here and I got this here, right? But I don't have a cotangent. I have a cotangent in my numerator, not in my denominator. So I have to do something about this. So I say, okay, what can I do there? So then I say, oh, I see a cosecant squared minus 1. This is a perfect square minus a perfect square. So I go back to my trig identities. And I say, okay, which one has cosecant squared in 1? This one does. I need to be cosecant squared minus 1. Cotangent squared would be on the other side. I need to get rid of those things after I do that. So this is replaceable with cotangent squared. That's what I'm going to do. I have cotangent of theta times cosecant of theta minus 1 over cotangent squared of theta. Okay? So now realize this right here is cotangent times cotangent, so I can cancel out one of the cotangents in the numerator with one of the cotangents in the denominator. How I like to do that is say I'm going to cancel out this cotangent with one of these. Yes, you could take an extra step of writing this as cotangent times cotangent and then canceling them out, but I know most people aren't going to want to do that. They don't feel like it. So now I have cosecant of theta minus 1 in my numerator, cotangent of theta in my denominator, which is what I was trying to get. So cosecant of theta minus 1 over cotangent of theta. Okay, here's our next one. So I have, which side is more complicated? Okay, so if you look at this, I have a fraction and then on one side and I have addition on the other side. Fractions are more complicated. So I'm going to work with this side. Okay, so similar to the last one, there's nothing that I can replace right now, especially this one, even like cosines or sines are ideal, and I have no squares. So I'm going to multiply by the conjugate. 1 plus sine of theta. 1 plus sine of theta. All right, so you should realize what you're going to do here. The whole point of multiplying by the conjugate of the denominator is to get that new denominator, which you can replace. 1 times 1 is 1. Let's actually write our numerator first. Cosine times 1 plus sine. And then my new denominator. 1 times 1 is 1. Outer and inner cancel because they're conjugates. Negative sine times positive sine is negative sine squared. All right, just like the last one, I'm going to say I can replace this 1 minus sine squared. So what can I replace it with? I'm going to come back to my trig identities. 1 minus sine squared. I would have to subtract sine squared to this side. I'd be left with cosine squared. So I can replace it with a cosine squared. So now I have, oops, I forgot my theta there. Cosine of theta times 1 plus sine of theta over, and then once again, this is replaceable with a cosine squared of theta. Just like in the last one, I can say up, a cosine cancels with one of these cosines. And now I have 1 plus sine of theta over cosine of theta. Now, the difference between this one and the last one is that's not what I was trying to get. I'm not done yet, okay? So I have to say, okay, what do I have to do? I'm stuck. I need a secant. A secant is the same thing as 1 over cosine. I need a tangent. That's the same thing as sine over cosine. So if you look here, I said I need a 1 over cosine, and I need a sine over cosine. You have it. All you have to do is divide. So I'm going to divide now. I have, and to show that I'm going to divide, I'm just going to keep it like this instead of writing an extra step. That's allowed. 1 over cosine is secant of theta. And then I have plus sine over cosine, which is tangent of theta. So I have secant of theta plus tangent of theta on this side also. The end. Okay. All right, which side's more complicated? Obviously this side. All right, so once again, what am I going to do here? I don't see any squares. I see lots of sines and cosines, which I leave. But I do see 2 fractions that need to become 1. So I'm going to get a common denominator. So this is similar to the first one, right? So I'm going to multiply by, I'm going to get the common denominator of cosine times 1 minus sine. So I'll multiply this by 1 minus sine over 1 minus sine. And I'll multiply this by cosine over cosine. All right, I'm going to write down what my new fraction is. So my common denominator is cosine of theta times 1 minus sine of theta. Notice I like writing the cosine first because I always like writing whatever's in the parentheses second. All right, my numerator, instead of doing the step here where I like wrote out this entire thing, I'm going to actually like do that in this step. So I'll multiply these 2 and then plus multiply the other 2. All right, 1 times 1 is 1. Outer is negative sine, inner is negative sine, so that's minus 2 sine of theta. And then last times last, negative sine times negative sine is plus sine squared of theta. Okay. Then I have, I'll change colors so we can all see it. I have this plus sign, so it's not a minus sign, so I don't have to distribute, so I don't need the brackets. And then I'm going to multiply these 2. Cosine times cosine is cosine squared, so that was way easier. Okay, so now I have to decide what I'm going to do next. Okay, so this is where you really have to like think, right? You have to say like, okay, what am I supposed to do? I'm stuck. Let's look to see what I'm trying to get at. I'm trying to get 2 secant of theta. Okay, so what does that tell me? This I know is 1 over cosine. And remember, I can't touch this side, so I'm just thinking out loud. 1 over cosine. I have a cosine in the denominator. That means this is going to have to cancel out with something. Well, in order for it to be canceled out for something, I have to do something about the numerator. So my thought to myself is do something about the numerator. Okay? So now I'm going to look at the numerator. I'm going to erase all this stuff that I touched over here because you're not allowed to touch it. I'm going to see, is there anything, do I see any squares? I see a sine squared plus a cosine squared, and I'm like, whoa, whoa, whoa. Actually, I don't like that I highlighted the plus sign too. I know that's the same thing as 1. So I can replace that with the 1. So now I can combine like terms. 1 plus 1 is 2, and then minus 2 sine of theta over cosine of theta times 1 minus sine of theta. Okay. All right, so now remember, I want this to cancel with something, but it can only cancel with the common factor in the numerator. So that means I have to factor the numerator because the numerator is not factored. The numerator has a GCF of 2. And now I'm like, ooh, this looks nice, right? Now I can say these 1 minus sine thetas cancel. And I have 2 over cosine of theta. So now I'm like, okay, now what? And I look what I'm trying to get. I'm trying to get 2 secant of theta. This is the same thing as 2 secant of theta because 1 over cosine is secant. So I can just say 2 secant of theta is equal to 2 secant of theta. All right, if you wanted to break it up like I broke it up here, you could. Or you could just say what I did. Okay, a couple more practices here. What side's more complicated? Clearly this left side right here. Okay. Now, before we get started, I would like to say that there are several different ways to do this. So if you do it a different way than I do and you still get the same answer, that's absolutely fine. Okay. All right, so what I'm going to do is I'm going to say that this looks insane. So I could start by getting a common denominator right now if I want. I'm going to hold off on that. I am instead, because if I get a common denominator, I still have cosecant, secant. I'm trying to get cosine squared over here. I just don't know if it's going to help me right now. So what I'm going to do instead is I'm going to say, well, I can at least, let's highlight what I'm talking about. I can at least change those to start to move this around. I would say that this is the most complicated one we do the entire time. So if I lose you on this, I'm sorry, but it's good to just know what to replace it with. What can I replace cotangent with? Cosine of theta over sine of theta. I have minus. What can I replace tangent with? Sine over cosine. Okay, but then I still have that over cosecant of theta minus secant of theta, and then I still have this plus 1. Okay, so now what can I do here? Well, I can subtract these two, right? But I need a common denominator in order to do that. So I'm going to get my common denominator, which is sine cosine. So I'm going to multiply this by sine over sine. And I multiply this by cosine over cosine. So now I'm going to fix this and say what I have, okay? That has a common denominator of cosine sine or sine cosine, it doesn't matter. Once again, I'm just looking at that circled part. And then I have cosine times cosine is cosine squared minus sine times sine, which is sine squared. Okay, now I could write over cosecant minus secant, but instead what I'm going to do is I'm going to put times 1 over cosecant times secant, right? Okay, because that's the same thing, right? If I'm dividing by cosecant secant, it's the same thing as multiplying by the reciprocal, which is 1 over cosecant secant. And then I have plus 1. Now, why did I do that? Because I'm saying to myself, wait a minute. 1 over cosecant and 1 over secant. 1 over cosecant is the same thing as sine. And 1 over secant is the same thing as cosine. So I can replace this. I can keep this cosine squared minus sine squared over cosine times sine. And I can replace that highlighted part with the 1 over cosecant I can change to sine. And the 1 over cosecant I can change to cosine. Now notice this is multiplication. Right here, this is multiplication. So that means that I can cancel out any common factors from numerator to denominator. I have sine and sine, cosine and cosine. So now I have cosine squared minus sine squared, right? Because this becomes a 1, this becomes a 1, and then plus 1 equals. And I'm like, okay, what am I trying to get to? Because I feel like this looks good. I'm trying to get to 2 cosine squareds. So I say to myself, like, you look good, right? You can stay, but I have to get rid of this. So I have to get rid of the negative sine squared plus 1. And I'm like, well, wait a minute. Sine squared is a perfect square. 1 is a perfect square. It's the same thing as 1 minus sine squared also. So I'm going to say, okay, what can I replace negative sine squared plus 1 or 1 minus sine squared with? Come back up here. 1 minus sine squared is the same thing as cosine squared. So I can replace this with cosine squared. So now I have cosine squared plus cosine squared, which is 2 cosine squareds, like I wanted to get. Do I think this is the hardest one that we do? I think so. So if you're like, oh my God, how was I supposed to get that on my own? I don't think I'd try to have you get it on your own at any point. Okay, it's just good to see ones that are a little different. All right, more complicated side is this right side. I'm going to get a common denominator. So that's 1 minus sine, 1 plus sine. So I'm going to do 1 minus sine over 1 minus sine. And then 1 plus sine over 1 plus sine. Okay, equal sign, new denominator. All right, so new denominator is 1 plus sign times 1 minus sign. And I'm like, I can write that right now because I didn't know good things were going to happen, but they are conjugates, so good things are going to happen. So you could either write that right now, what I just did, or you can multiply them out and write what's there then. It doesn't matter to me. Okay, here I need to multiply these two plus and then multiply these two. So distributing a 1 is easy because it's 1 plus sine of theta. Then I have the plus sign, distributing a 1 again, 1 minus sine of theta. All right, so I'll clean up my numerator and then clean up my denominator. So 1 and, oops, I crossed it out. When it's 1 and 1 is 2. Sine and negative sign cancel. I don't like how I wrote through that. Here we go. 1 and 1 is 2. Sine and negative sign cancel. So I have that 2 right there. Okay, my denominator. I can multiply those out. And if you're like, they're conjugates. Multiply conjugates out, okay? So 1 times 1 is 1. And if you're not sure, look what you're trying to get. You're trying to get secant squared, which is 1 over cosine squared. 1 over cosine squared. I need to get 1 over cosine squared there. Okay, so 1 times 1 is 1. That's first. Outer is negative sign, inner is positive sign. They cancel. Last times last is minus sine squared. Now, once again, you're trying to get secant squared, which is 1 over cosine squared. That means that I have to get rid of this. So I say, what can I replace 1 minus sine squared with? Come back up here. 1 minus sine squared would be cosine squared. We use that a lot, notice so far. So 2 over cosine squared. And then once again, my goal is to get 2 secant squared, which this is the same thing as 2 secant squared of theta. 2 secant squared of theta. Okay. All right, that's it for today's practice. You can go ahead and get started.